Here's another example of a complex fraction. It's a fraction that has fractions in its numerator and denominator. We want to simplify that complex fraction. And the technique we use is to pick a multiplier that will at least cancel the fractions, cancel the denominators of the fractions that are in the numerator and denominator of our overall fraction. That way we will eliminate them and simplify the fraction. The multiplier that I would need to cancel the denominator of this fraction would be x plus 1. But that wouldn't be good enough to cancel the x that's in this denominator, because I can't cancel an x with an x that's tied up with plus 1. Remember, we can't cancel when things are involved in addition and subtraction. So I would need a separate multiplier of x to cancel the x that's in that denominator. And likewise, wouldn't x times x plus 1 cancel the denominators that I have in these fractions? Make sure that that's an x plus 1 and doesn't look like something else on the video. So I want to multiply these fractions by the pair of factors x, x plus 1. So I'm going to take this term and multiply it times x plus 1 minus this term multiplied by that pair. See, I'm distributing this multiplication across both of those terms. And I'll have to do the same thing here, will I not, in the denominator? So it's x over x plus 1 will be multiplied times that pair, x times x plus 1, plus 1 over x, again, multiplied by that pair. And now let's look at whatever canceling we can do. Well, the x plus 1s will cancel here. The x's will cancel here. The x plus 1s will cancel here. The x's will cancel here. Now let's multiply what's left. What's left here? X times x, which is x squared. Minus 1 times the binomial x plus 1. So that's minus 1 times x, which is minus x, minus 1 times plus 1, which is minus 1. That's now the numerator of my new, less complicated fraction, my new simple fraction. X times x is x squared, plus 1 times that binomial. Plus 1 times x is plus 1x, and plus 1 times plus 1 is plus 1. There's our simpler, our no longer complex fraction. And then we would take a look at those trinomials to see if perhaps they were factorable, and we could cancel some common factor, which in this case they are not. So this fraction is equivalent to the original complex fraction we have. And even though it still contains a trinomial in both the numerator and the denominator, we no longer have fractions within a fraction. We've been able to eliminate those interior fractions to the overall fraction. We've been able to eliminate the complex fraction.